Welcome back everyone to our class. This session we are going to practice our program, writing some code and to do some coding in order to execute what you want to do. Okay. And before proceeding further, please do not forget to download our data that I sent to you via our Facebook chat or via our Telegram. Without this data, you can't do much because we are learning, we are discussing online. And if we have different data set, it is very difficult for everyone to follow what I'm teaching. Okay, so please be ready, download the data into the folder that you want to work it on. Okay, so please let's have a look on our recorded video that I have made for you. I like the previous session as well. I made it shorter so that the other unnecessary session is cut out. Okay, so let's have a look. And if you have any question, please do not forget to drop me a message. I will be answering your question as soon as I can. All right. So here in R, when we type hash sign like this, okay, everything after the hash sign is just a note, whether it is written as a code or not a code. It will be regarded as a note, okay? Now I make a note. The first step is to load the data, okay? Using the environment panel on the upper right. Okay. Yeah. Even if just one hash or two hash, it is the node. Okay. Import data set in the environment panels on upper right. Okay, here. You can also use command in order to upload the data, but it depends on the types of data that you are going to upload. If it is Excel, you have a different code. If it is a text file, you need a different code, okay? Or if you have a CSV file, then you need a different code. To be easy, you just need to click on the import dataset on the upper right panel in the environment working space and click on import dataset. Right? Then you need to import from Excels because our data is in Excel, right? Okay, click Excel. Then it appears a screen like what is shown here. So you need to browse. Okay, click on browse. Choose the destination and the files you are storing. In my computer, I store in a folder, okay, here in the teaching and then in the Philippines and then Ramblin State University. And here is the data, data_practice1. Okay, click on it and open. All right. Then you will see the program show you right here the characteristic of each variable. So the first variable is respondent number 1, number 2, number 3, number 4, and etc. And it is represented by number. Age, okay, it is here. Sex is character, okay. Number of children, double, it means number. Main job, it is character, okay. So that is a brief information about data that we are going to upload. Now let's go below here. See the name. In programming language, whether it is in C++ or in computer program or in statistical program, the name of the data or the name of your vector or the name, other names need to be short, easy to be read, okay, and easy to be execute. And now, please follow me. If I use what name, please use the same as mine so that it is easy for us in the class to follow. Otherwise, we may got lost. Okay. I name this data that we are going to upload as df. Okay, df. I take the first row as the name of the variable. Okay, it is automatically ticked for us, which means the first row here means respondent and age and sex, etc. These are the names of each variable, right? Okay, sheet. If you have many sheets, you have to indicate, you have to select whether sheet 1, sheet 2, sheet whatever. But if you don't change anything, you select the default, then the program will upload the first sheet of the Excel automatically into the R. Okay, so it's ready. I import. Everyone, you can see like this for further use, and it is easy for you, no need to import again, and you're working on the same data set. Please copy this code, okay, into your editor. So you can now close your DF data, okay, and now here on this editor, okay, I can paste. Don't forget to delete the bigger sign here, okay. So line number 5 here, number 6 here, you can just keep it there for a later use, a later practice. You don't have to import again. We use this command, this code for the R to call the data in, all right? So in order to read the Excel's file into our program, we need this library, okay? Need first this library. For later use, when you close this R program and then open and rerun the code, you need to run from line number 5, okay? Otherwise, line number 6 can't be executed, okay? All right. Now we have the DF already. On the upper right, you can see DF. And in the middle, you can see 44 ups of 10 variables. Anyone can tell me what does it mean? 44 ups of 10 variables.
Observation, sir.
Good. And 10? And 10?
In 10 variables po.
Right. Okay. So if you go to your Excel's file here, right? So from 1 to the end, you can see it is 4, numerical count 44, 44 sample. And variable from A, okay, from A to J is 10, all right? So 44 ups of 10 variable, meaning that our data set named DF contain 44 samples of 10 variables, all right? So in R, you can do some simple code. For instance, if I want to know what are the variables that are inside the dataset named DF, then you can write this code, okay? Names. So names, it is a code function written in the base library of R, okay? Then you open the bracket. So inside the bracket, what do you want the function name to execute on? What data? So in our case, it's DF, all right? So I want the program to show me what are the variables that are inside the DF dataset. Then you can execute. By doing execution, you can use your cursor here. You can put wherever you want in that line, okay? At the end, in the middle, in the first, okay? If you want to execute that line, put cursor in any line, and then you can click on run, okay? Or you don't have to use your mouse. You can just use control, press control together, and then enter, control, enter, press it. Okay, in my case, I press control, enter now. Okay, so the result show in the console here. Okay, you all get that? The same? Here. In the DF dataset, we have the first variable named respondent. So the number here, it corresponding to the number of the variable. Variable number 1, the respondent. Age here, even if it has no number indication, but it is number 2. So you can count 1, 2. Okay. So age is on the second column, variable age, and variable sex on the third column. It is the third variable. And fourth here, number of children. Fifth, main job. Okay. Sixth, main job salary. 7, additional income. 8, total income. 9, expense for children. 10, other expense. Okay. You all come into this now?
Yes, sir.
Good.
Yes, Doc.
Good. All right. Okay. So I can make a note here. Okay. Showing the name of variable y in df. Okay. Right. Okay. And if you want to subtract df into a smaller set of data, you can also do a lot, right? And if you just want to see some first row of the df, you can write this code. You can say head df. Okay. Meaning that the program show you the first 6 lines of the dataset, okay, of some variable that can be appeared on the screen here, okay. It shows the first 6 lines. So showing the first 6 lines of df. To see the tail, the bottom lines, so you need to write tail, okay, tail df. Okay, so sample number 44, 43, 42, 41, 40, and 39. Okay, so 39, the respondent that we interview has the age of 27 years old, who is female. She has 2 children, and she is now a manager in a company. The salary she gets, 800 per month. Additional income she gains, 134. Total income then, 934. Okay. And number 40, number 41 up to the last sample, 44. Okay, so we just use the command showing the last 6 lines of df. Okay, all right. Subsetting df. If you just click on the df, it will appear the data. I want to subset the data corresponding to the main job as a manager only. Okay, all the variables are the same, but the sample are only from manager. Okay, here. So I name this subset df as df managers. Okay, mngs manager, from where I am subsetting. Okay, from df. And to subset, you need to use the df with the square bracket. And the square bracket of a data frame or data set is divided between samples and variable by a comma. Before comma, they are the sample rows. After the comma, they are variables. Okay. All right. So in order to get just the data of managers, okay, you need to get here. So managers, we have, okay, respondent number 21, respondent number 23, 25, and so on. So we need just only that sample. Okay. So we can use other function. We can say which is also a function, df dollars, and the variables that indicate the job category is here, main job. Then equal managers. Okay. So this code will be executed to extract the sample collected from manager only and all the variables are the same. In total, 10 variables. Okay. If you want to know whether this code is working, you can just select this code and then execute. Okay. So they are working here, right? So if this half is working, now let's run the whole. So here, you can see, you can subset now. DF manager, only 13 observation, 13 sample, and number of variable are the same. You can view it. Okay. So earlier, we go through data and we mentioned that row number 21, 23, 25, 27, and so on, they are all managers. And now we get only on managers. Okay. No normal staff, no team leader. All are managers. Okay. Right. Go back to this one. Okay. So here, sub setting only the data of manager. Okay. You all get that?
Yes, sir.
Okay, good. Others?
Yes, sir.
Good. Only two. How about others? Get into line 12, subsetting the data. I got just only two answers. How about others?
I must have gathered the data, sir. However, it did not appear in the in that environment panel.
So what do you see at the console here?
It's
There's a problem.
walang subsetting.
So if an error message appear here, then your code is not correct. Okay. If a red writing here, okay, saying error, it means that your code is not working.
I got the
So
data,
Brian-
sir, of the managers. However, it did not appear or it did not register on the upper right panel.
Okay. You're also using RStudio, right?
Yes, sir.
Okay. Can you show us? I mean, can you share screen so I can see?
I am actually logged in using Teams in my phone, sir, and
Hmm.
the laptop is using the RStudio, so I can actually share screen this one.
Oh, okay. And how about selecting only DFMNG? And afterward, you execute. Did you see something on the console? Here. If you see the data like that, it's working. If not, there is an error message. With line number 8, please unselect where you selected, unselect it, and put the cursor anywhere on the line, and then just execute. Afterward, you will have the data on the environment, the DFMNG on the environment.
It's
You get it
okay
now?
sir. Yes, sir. I get it, sir.
Okay.
Thank you.
Okay. Yes. Great. All right. So this is one of the subsetting way. Another way, I say that, oh, I just want to subset another data. Okay. And this subsetting, okay, I use DF. Okay. DF first 10 line. Okay. First 10. Okay. 10 line. Then subsetting from what? From where? From DF. And then I need all variables, but from first 10 line. On the place where you indicate the line or the sample, you need to put 1 and 10. Okay, meaning that you are now subsetting a new data from the DF that contain only the first 10 sample of all 10 variables. Okay, so here subsetting only first 10 lines of DF. Okay. All right. So from DF, okay, you can execute now. Now here you can click DF 10 line here. So respondent number 1, number 2 until number 10. You can subset like that. what if I want to subset, okay, a new smaller data that contain only the variables that has a quantitative measurement. So quantitative measurement, there are variable age, number of children, job salary, okay, income, expense, and income. For easy, now, I just want to subset the data, the first 10 lines that contain only every variables related to income and expense. Okay, so variable related to income and expense include main job salary, additional income, total income, and for expense include expense for children and other expense. There are 5 variables. Okay, so here DF 10 line new. Okay, I want to subset, and then DF first 10 line, and then you need to know what column, what variable, and what stands all the expense and income variables are. Okay, here, in this case, you need to go and see the name of the variable. Okay, or you can say execute again here in the consoles, name DF again. Okay, what column? All the income. Please tell me what are the number of variables that related to income and expense. From what column to what column? Please tell me. Incomes, every variable is related to income, every variable related to expense. So from which
10.
variable? What?
From 6 to 10.
From 6, okay, here 6 main job salary, all right? So from 6 to 10, good. All right, so here you can say 6, okay, and 10, okay? 6, okay. 6, column, 10. Yes, please, what did you say?
What is the symbol like after the df.10
L.
Which one?
in
L.
the L? Is it
4 lines.
line?
L.
Letter L, sir.
L. That
Which,
N.
oh, this one?
L. Okay, sorry.
Yes,
sir.
it is L, yeah, L. It's just a name. You can, yeah, you can write like 10 LI or whatever, okay? 10
Thank you,
lines.
sir. Thank
Yeah,
you.
so let's say here, 10 line. So if you have a new name and execute it again, then it will register at the working environment on the upper right, okay? Okay, right here, here. So for the line number 14, that we want to subset the data of DF for the first 10 lines containing only variable related to income and expense is now executed. And let's see here, okay, DF 10 line new, okay, see, you can do the subset like that, right? So only the variable related to income and expense only, and only first 10 sample, all right? So this is subsetting. Afterward, you can delete all the view of data to make sure you have not many tabs of the editor's panel. Okay. What if you want to subset line number 1, okay, and then line number 3, and then line number 10? Okay. So you subset all the first 10 line of DF containing, just make a note for you, then I can send the code to you, containing variables related to, we can say, all variables. It's too long, then I can put here. Below is the subsetting, okay? Or you can say just subsetting. Only first line of 10df containing or variable related to income and expense. All right. Okay. And here, subsetting line 1, 3, okay, 5, 6, 7, 8 of df containing variable containing var sex, or let's say age, and then job category, total income, only 4 variables. Anyone give a try how to subset this one? You can name a new data set. You can say df2, okay, and then subset from df, okay, and then square bracket for rows, for example, line 1, 3, 5, 6, 7, 8. Okay, so it is if it is not a suite 1, 2, 3, 4, 5 like that, if it is a jump somewhere, we can't use column alone. We need to use C, concatenate, and then write all the number here. And if they are suite like this, okay, 5, 6, 7, 8, you can use column 5 to 8. It means 5, 6, 7, and 8. Okay. And for variables, you need to know where this variable stands, which column. All right. Or you need to write exactly the name of the variable. Exactly it is. Okay. You can use number or you can use exactly the name. For the number that representing the column. So age in what column? Age here.
2.
Yeah, 2. And then sex, 3. 2 and 3, you can use comma or colon. It's all right because it's just only 2 and 3. And job category. Job category is main job. Okay, so what column? What column? Job category is main job. Yeah, number 5. Good, good. Number 5. And the last is total income. So which column?
8, sir.
8. Good. Okay, now you can execute. Okay, so a new DF is for you, DF2. Okay, so we have only 6 lines and 4 variables. Okay, age, sex, main job category, and total income. So this is subsetting. Okay. Most of the time we are investigating or we are studying the variables regardless of sample, but somehow we need to group sample together according to the job category, according to the region, to the place, or gender. Okay. Below is subsetting single or more than one variables. So here subsetting one variable, or we can say extract data of variables, of each variable. Okay. If I want to extract a data of age from df, you can use the $sign. Okay, here. Age. Okay. So this is just a command that will provide you the answers if you execute. But if you do not name this code, then the data will not be registered in the environment. Okay, you get what I mean? If you just write a code and execute it without naming, then it will only provide you the result in the console. But it will not be registered at the working environment on the upper right. Let's see. Line 22, DFH. If you run this code, execute this code, you get an answer in the console. Okay. Sample number 1 has an age of 25, 2, 23, 3, 26, 26, 27, up to the last sample who has an age of 31 years old. Okay. So this data is not registered in the environment here. If you want to register it for later use and a short name, you can provide the name of this code. Okay. But if you provide every names of every vector, so this is called a vector of a data of one variable is called a vector. Okay. If you want to extract and show the data of the main job here, okay, you can just write df dollar and then the name of the variable, execute, you will see. Okay, here. And if you want, okay, here, seeing or showing every data point of var main job. Okay. If you use, for instance, tables, okay, df main job, then it will provide you, the result will provide you the frequencies of each category of the variable main job. Okay. Sorry. If we want to see how many cases or how many sample collected from normal staff, how many sample collected from team leaders, how many sample collected from managers, we can just use the function table, and then inside the function, you need to indicate clearly what variable you want to execute. In this case, it is main job category. It is the result. Okay. So manager is only 13. Normal staff, 16. Team leader, 15. All right. So is this the frequency of each job category? Okay. Right. Up to now, the 24th line, everyone follows us? Or any issue encountered during your execution? Any issue encountered?
None so far, sir.
Good. Others? So far, so good. Marisol, Cedric, Shanna? Good.
Good, sir.
Okay.
Yes, sir.
Okay. Right. Subsetting data. Now I think we have some like experience, some practices already. Next, we need to do some descriptive statistics. Okay, descriptive statistics of the variable. Here, yeah. So I need to take the code here. So showing the frequency of each job categories. Okay. All right. Now let's move to doing some descriptive stats. Anyone? Descriptive stats.
Measure of central tendency, sir.
Okay, measurement of central tendencies, including what are they?
Mean, median.
Mean and mode.
Yes. Mean, medians, mode. What else? Range, min, max. Okay. SD, variance. Okay. Practice on the var age. Okay. Now we are doing a practice on the variable age. In total of 44 observation, 44 samples. What is the average age? Okay. You can say, you can just execute a single code like mean, df, age. Okay. So 29.3. Okay. It's 29.3. Okay. Min, you can say just min. Yeah. df, age. Okay. So 21. Okay. Max. df, age. 39, 49. Okay. Median. df, age. 29. Okay. Or you can use a collective code that provide you most of these measures. We say summary. Okay, df, age. So you have mean, first quartile, median, mean, third, max. All right. For each quantitative variable, you can also do a box plot. Box plot, df, age. Then you can see here it is a box plot. So 49, it is an outlier. The respondent that you were interviewing is really old compared to the majority of your respondents. Okay. On average, the people that you went out to do the interview is 39. Sorry, 29. Median is also 29. Mean and median are more or less the same. Okay. Right. And based on these graph, can anyone guess whether this data follow a normally distribution or not based on the graph? I mean, based on a box plot. Sorry, based on the box plot, can you guess whether the data of age of 44 samples, they follow a normal distribution or not? Just guess. Mm-hmm. Any wild guess?
Wild.
No, sir.
No?
No, sir.
Okay. So if a data is following a normally distribution, okay, the first half and the second half below and above the median are more or less the same length, especially between the second to the third quartile. The length, the distance are more or less the same. The distance from the second to the first quartile. But in our case, the distance between the first to the second is almost, or maybe almost is double, right? From the second to the third. Do you agree? Do you all agree? So here is the first quartile, and here is the third quartile, and the black horizontal line here inside the box is the median, or the so-called second quartile. So from the second quartile to the first, the distance is double the distance from the second to the third quartile, right? Do you all agree? Yeah? No? Yes? No?
Yes, sir.
Yeah. Okay. Here, right? See, bigger. The black horizontal line on the inside the box, it is median, or called second quartile, right? And the bottom of the box here is the first quartile. And the upper part of the box is the third quartile. And if we look at the distance between the first to the second quartile and from the second to the third quartile, they are not equal, right? The first to the second is double longer than the second to the third quartile. If it is not more or less equal like that, the distribution of the data has a high chance of not normal. But like we discussed previously, to have a black and white decision, normal or not normally distribution data, we use Shapiro test or Kolmogorov-Smirnov test. Just figures, just box plot, just frequency plot. They are just figures. They can't tell us which is which. Okay. But for us who have experience in doing data analysis, data illustration using figures, you can just take a look and you can already give a guess, or you can already provide a hypothesis that, oh, this data is not normally distribution. You can say like that. If it is really deviated from the equal length, it is the more and more high chance of being not normally distributed. Okay, so this is just a recap about normally or not normally distributed data. Okay. How about computing SD? What is SD? Ellie?
Standard deviation.
Okay, thank you. Okay, SD. You just say SD, and then the variables that you want to do the SD. H. Okay, so the standard deviation is 5.58, or let's say 5.6. Okay, so we can say the average is 29 point something, 2, and then plus, minus, minus, plus 5.6. Okay, 60% of the data falls into this range. Okay, which equal to what? How about variance? You can say just var, EF, H. So variance is here, 31.2. All right. So yeah. You get to this execution until this one.
Yes, sir. VAR.
All right. Now I would like to have one of you showing your screen and select one variable, compute the descriptive statistic of that chosen variable, please, and share the screen.
Again, sir, what are we going to do?
No, I just would like to have one of you, a volunteer, okay, to share your screen and then selecting one variable to compute the descriptive statistic of that variable. Okay.
Can I try, sir?
Okay, please, Ronald. Yeah, go ahead.
Sorry, sir, my screen is yung the Ivansin, sir. I
You should.
need to the laptop and at the same time my phone because it's hard to follow. You just have one device.
So you can use your laptop?
Yes, the name Ivansin, sir.
Good. All right. So what variables are you going to show us?
So, if we are using descriptive statistics, normally we're dealing with numbers. So
Okay.
from different variables that we have here, like income, maybe, and yan, total income.
Okay, good. Okay, now let's
Okay,
do
the total
total
income. So our object is DF. Then, no. Let's check first.
Okay.
And DF in our console, and total income.
Okay. Right. Good.
Then run.
Yeah.
So we can see from our console, no, there's an error.
There's a box plot somewhere.
Let's check.
Go to the very bottom of console.
Box. Total dot income. Yes, total dot income.
Go to that income. Yeah.
So,
I think it's good. It's good to go.
but it does not appear on the screen, sir. Am I
Can you run?
correct, sir? Or running?
Can you use the cursor put in the very bottom of the console and press escape in the console panel? Yeah, and then press escape. Okay, and then you can execute the DF again. DF total income.
Okay.
Then you need to fix the lower right panel, panels. Maximize a bit or enlarge it a bit to the middle half. The plot area. Yeah. Okay. Then can you box plot H again? DF line number 25.
Box
Yeah,
plot.
actually. Yeah, box plot DF H. Because an error is about box plot. Okay. DF $H. All right. Can execute. Okay. Now I think you're good to go, and the total income is already appear on the console. You can see that?
Yes, sir.
Okay, good. Now we can
So
do
it's
the
hard to run
descriptive
in
stuff.
our studio actually.
Yeah.
Then that's the total income. Then so in measure of central tendency, we always
Mhm.
compute for the mean, median, and mode.
Mhm.
Yes. Then for mean, DF. Then the variable start
Yeah.
always with $sign.
Yeah.
And actually, we have also IntelliSense, so it's easy for us to write the code rather than to type it
Mhm.
letter by letter. So execute. Can I
Yeah.
execute this one, sir? For the
Yeah.
mean. So
Okay.
for the
So
mean, we
total
have
income $543 US dollars per month. Okay, I think you're good to go. And the other, you just change the code, yeah, and do the
for the
summary.
summary.
Yeah,
So actually, it's my first time to use R.
it's good. You can use this. I think this is good already. Okay. Okay, minimum 200. Minimum is 230. The first quartile is 359. The median is 424. Mean 500 something. Third 600. Max. Oh wow, it's a big one. Yeah. Can you do a box plot of the total income?
Okay, sir.
All right.
Okay, the box plot.
Okay, yeah. So the three samples that are outlier. You can also enlarge the plot panel to a bigger, so you can see clearly the distribution. All right. Everyone else, please save some time at home, and then you can practice doing some similar things before our next session during the weekend. You see the code? I mean, see my R screen?
Yeah. Yes, Doc.
Okay. So
Okay,
on the
yes, sir.
editor panel, so on the upper left here, this panel we call editor panel. You will see one here, untitled, okay? And you may see other like a table, like DF2, DFMNG, something like that. These are just data you can close. What is important, like Microsoft Word, Microsoft Excel, Microsoft PowerPoint? When we close, you can save, okay? Click File and then Save As, all right? Save As, and then you need to find the location where you want to save, all right? So I will save in our folders. So in your folder, up to you. For me, here, okay. So R practice. Okay. That's all for me. Okay, I save it. After saving, it will show the name that you provide it to, and the red color of the name disappears. If you change just one space like that, so the name will become red, meaning that this code has not been saved yet after your updating. Okay, so you need to save again, or you can just Control S, save. Okay. And for this session, it is a very simple execution. When we close R here, okay, and right across the red cross on the very upright, when you close the R, the program will ask whether you want to save the workspace or not. Okay, so I close here. See, save workspace image. In this case, please don't click save, just click don't save. What is important is the code here. Okay, all the code here we have already saved. We save code already, and the code will provide you all the results. then you don't have to save the workspace that you have executed so far, including the figures and the number, whatever, because it is so quick to execute and get the result. The case that you need to save the workspace is the time that you run simulation, you run prediction, you run forecasting that take up to 1 day or half a day or up to hours. In that case, you need to save the workspace. And if it runs just less than a second, you don't have to. Okay, no need. Otherwise, it will be heavy in your computer. All right. Okay, yeah, that's all for today. I hope you get something, and we will go through together in the next weekend. I mean, this coming weekend, explore more practice. All right. If you have a question, we can discuss a bit more. Otherwise, we can dismiss our class.